And I thought we'd take a few seconds and talk a little bit about 3D scanners. And I wanted to talk about 3D scanners specifically because I got a question on my Patreon account. Hey, everybody. Appreciate you guys coming to hang out for a few minutes. I got an email this morning from one of my patrons asking specifically about 3D scanners. And it's tough because it seems like every time you go find 3D scanner data, the people that are sharing the information are either A, trying to sell you something, B, have an application that's maybe way outside your budget and or price range, or C, just don't seem to have a real good handle on it, or maybe they're doing it as a hobby or something like that, and which is problematic. And so what I wanted to do is just answer this question. So the first question I want to answer, because this live video is being made specifically for one of my patrons. He says, how has the Eastwood air compressor been doing? The answer is that compressor did great for a few years. It's just a backup. It's just an air tank. It's just a backup for the shop now. If we needed it, we could plug it in at any given time, and I'm sure it would do its job just fine. The other question is, my man here is looking to get a 3D scanner, and he wants to know a little bit about it. And so I have now owned 3 different 3D scanners, and I'll give you my take on it. My first ever scanner was the Peel 2, which just so you know, basically there's 2 fundamental types of scanners out there. There's structured light and laser. And anything cost effective is going to be structured light for the most part. And there's a variety of things that differentiate these scanners, but the resolution, the accuracy, things like this. Can it pick up color and texture? This can make a big difference. So you can see I got this Stormtrooper helmet. This was done years ago. In fact, three years ago, I don't know, a long time ago, with a good old-fashioned Peel 2. Now, Creaform is a company that makes the Peel 2. What they did is they had a couple of old technology industrial units, the GoScan 50 and the GoScan 20. And what they did is they kind of repurposed these scanners for the consumer market. Now that they have the higher level laser scanners, they repurposed both of these GoScan units, and they renamed them the Peel scanners. And so the regular one, the Peel 2, they injection molded the handheld unit white, and they just kind of like in an Apple-esque fashion, and that's the GoScan. That would have been what you would have compared that to a GoScan 50 10 years ago. And the GoScan 20 is known as the Peel 2S, or small version, or whatever. And the 2 big differences. Let me just give you. I'm going to give you guys the summary now. That way you don't have to stick around too much if you don't want to. 3D scanning is incredibly useful for a lot of reasons. There are a lot of myths. It's still a process. It's not magic. You don't scan something and then hit go and make it. It just doesn't work that way. Okay. So the first time I bought the Peel 2, I liked the scanner. It was basically accurate enough, but I never found a way to use the data in CAD inside SolidWorks. There just wasn't a good workflow. And so you had to buy the scanner for, let's just say, 10 or 12,000 bucks. I think it maybe 10 grand. I can't remember now. It's been a long time. Maybe 8 or 9,000, whatever. You get the point. A lot of money. And then you had to go buy like another piece of software like VX Elements or Geomagic or some another 10 grand, just so that you could take this 3D scanned mesh data, because 3D scanners create PLY, point cloud files. You can then take this point cloud file that's created by the scanner, clean it up, and mesh it. And when you create a mesh, that's generally an STL. There are other forms of meshes like OBJs and things like that, but that's deeper than we need to talk about today. Well, So I bought the first one. It did a great job of scanning, but there was no real workflow that was cost effective. We didn't have another 15 grand for Geomagic. So it went back. I thought it was a cool product. One of the things I liked is that it had a really big standoff distance, which means that when you're actually scanning something, you could be, 15. It had a very big, for all you photography guys out there, it had a pretty decent depth of field, and that was incredibly useful. It had a scanning area of, like, let's just say 10 by 10 or 15 by 15 inches, a very big scanning area. It was a very forgiving, easy scanner to use, but we couldn't use the data in CAD, so it ended up having to go back. It was worth a try. It didn't work out. Fast forward to a couple years later, I find out that Creaform is selling Peel 2S CAD. They've now integrated into their traditional software suite, they've integrated CAD features. Now, this is magic. You scan your object, you can select a group of vertices, and you can create a plane or a cylinder, cone, all kinds of cool stuff. You can then export this reference geometry out into a CAD modeling system of your choice. For us, it was SolidWorks. So basically, you could, which was awesome. The problem that I had is that instead of getting the first scanner, the Peel 2, I got the Peel 2S, and it was a very useful to scan something that was like maybe the size of your fist. It was awesome. But if you wanted to scan something that was, say, the size of 2 or 3 shoe boxes or anything like that, it was just, its depth of field was so ridiculously small that as you scanned across something like this, right? Here's your beam, let's just say. Here, it would say, yes, you're positioned perfectly. But as you twisted this way, because this gap, because the distance was so much longer here compared to here, all of a sudden, scanner has lost track. And so you had to use way more targets. It was a pain in the butt. Lo and behold, even though I spent the money, I was actually quite happy with the possibility. I tried calling them back, and Creaform actually had 2 scanners available in my price range. They basically have an ultimate deal. You can go look now. You can get both scanners, the Peel 2 and the Peel 2S, with the CAD software. I think now it's 16 or 17,000, but at the time, this is about 6 months ago, it was 15,000. And I called them back and said, "Hey, listen, man, the depth of field is just making my life a nightmare. I would rather just scan with the Peel 2 scanner, and then for the areas that need lots of definition, I'll just use the high res scanner for those segments. Can I just pay the additional $5,000 and get the whole combo?" And they said, no, you can't do that. They said, "We're sorry, but once you've made the purchase, it is what it is." And so I just said, no, then I want a refund and to return the scanner. And more importantly, they had also told me that you could trade up. If you buy a Creaform scanner, you can trade up within a year, which means whichever you spent, if you spend 10 grand, 15 grand, you can box that stuff all up within 12 months and you can send it back towards an upgraded scanner. And so I wanted a HandyScan Silver, right? This is an entry level laser scanner. They had told me that I could do this. What they did, they told me that basically I had spent, I want to say around 11,000 on the Peel 2S CAD program. Well, when I said, okay, fine, if you won't let me do the ultimate combo, that you offer to new customers, I'll just go ahead and take the HandyScan Silver, for the extra 10 grand. And then I was going to have a laser scanner. I was pumped. Well, then they redact, or they remove the software package that you used with your light scanner so that you can't use it. So if you spend the extra 10,000 to get the laser scanner, now you can't use any of the software that you already have. So now you have to spend 10,000 to get the laser scanner, and then it was another 7,000 for their CAD package. So it wasn't a $10,000 upgrade with trade-in. It was a $17,000. Needless to say, this left me super bummed. I don't feel like I was like betrayed or deceived. I just feel like there was a really bad job of educating me from the organization. And I said, "Listen, man, I don't have $17,000 to give you guys for a laser scanner. And even if I did have it, I don't know that it generates that much value for the business. 10,000 was stretching it for me, but whatever. And so I sent it back. And then I stumbled on to one of these Instagram ads. I'm sure you guys have seen plenty of these Instagram ads. And I saw it for this little bad mamma jamma right here. And so before I open this case, I want you guys to know that when you buy a 3D scanner, I hope that you have a very specific workflow in your mind. What is it you're trying? What are the goes and no goes? Where do you draw the line? What makes it worth it? What does it have to do to perform to justify its investment? And what do you expect out of it? Because this you could end up being heartbroken if you don't. This is one of those little RevoPoint Pop 2 3D scanners. Everything in this case I bought for $799, and I will tell you that it's got a calibration target. It's got a calibration target right here with some another like little disc, a little turntable disc. It comes with a little statue for testing, a motorized turntable, a tripod, and then it comes with this little structured light scanner, which is this right here. That's it. And I'll tell you right now, this thing is worth every single penny. I paid for this. This wasn't given to me, nothing like that. I paid for this. If something like this can satisfy your needs in 3D scanning, I would say 100% this is worth the investment for $800. They actually have, I want to say its accuracy is down to like maybe less than 0.1 millimeter. 0.02 millimeters is 1,000th of an inch. There's actually the RevoPoint Pop Mini, which they claim is accurate down to about 1,000th of an inch. The rub here is that all you're going to get from these types of inexpensive entry-level structure light scanners are meshes. It's not incredibly useful in CAD if you're using something like SolidWorks or Inventor. However, Fusion 360 has continuously upgraded their mesh modeling environment, which is pretty amazing. And so you can take a mesh right off, you can scan everything in, clean it up in the Revo Studio, and then you can take it right into Fusion. Now, keep in mind, these are not models that you're going to sell or manufacture. Generally speaking, what's going to happen is you're going to scan something in, you're going to generate a point cloud, you're going to take it into something like Mesh Mixer or Mesh Lab or Blender or one of these editors, and then you're going to use it as reference geometry to create your own part. My speaker just shut off. There are some really interesting capabilities. I actually just purchased the plastics trial extension here in Fusion here recently. And so it does some cool things. So you can take your mesh body, you can save it off into like a BREP, and then you can ultimately export your mesh into a step file. And then if you wanted to run it through SolidWorks or something like that, you could. So 3D scanning is one of those things where it seems super easy on the surface, but the deeper you dive into the discipline and the workflow, you'll see that it gets demanding on your hardware requirements quite quickly. Quite quickly, you need quite a bit of RAM to run these things. And one other issue: none of those Peel scanners. This laptop that's behind me is a Lenovo. It's one of their gaming laptops. It's got a, I want to say it's got like a RTX, I don't know, 2070 or 3060 or something. But it's got Windows 11, and none of the Creaform Peel scanners would work on anything with Windows 11. It had to be Windows 10 only. So I'm sure they'll get that sorted. But just if you're going to buy a scanner, it's worth knowing. So, anyways, depending on what you're doing, there are some incredibly unique workflows. I know a guy in Germany that runs a super high-end 5-axis machine, and he has I think it's called the Metra. He's got a super high-end scanner that could be LiDAR. Some of these could be LiDAR, yeah. They say structured light LiDAR. Yeah, there's a variety of different ways of doing this. Some of them are infrared, from what I understand. Um, but if you're willing to spend 100 grand on a scanner, you could literally machine a part in your 5-axis mill, scan it to verify it before it ever comes out of the mill, uh, and then make any corrections or send off that verification to the person that needs the mold or the part or whatever. So I'm going to read through the comments real quick, you guys. I've got my iPad here. I'm going to read through these comments. I never intended for this to be the longest of live videos, but I thought it would be cool to do one and answer this question for my patron. And so that was really my ultimate goal in doing this. Let's see what we've got here. Okay. Outside budget and price range sounds like all CMM. Sounds like all CMM arm systems. I've worked with CMM arm attached laser scanner. Scans accuracy is limited to about 0.04 millimeters. Yeah, it depends on the technology. Someone says, I'm scared to buy one and end up spending too much time cleaning up the scan file. It just depends on what you want to do with it. Most of these scanning software suites have this ability where after you scan your object, especially if it's on a flat surface, you can just lift it right up and boom, that plane is gone and you have a pretty clean model. If you've done a good job and you've been patient, you won't have any holes or bulges or anything, any kind of goofy, awkward geometry. If you do, or if you find something that you want to scan that's quite large, you can scan it in segments, and then you can go in later and you can align it based on reference geometry or targets if you apply targets to your model. Let's see here. Since it's just a reference to work around with native geometry, how much editing does this mesh need? Generally speaking, when I scan something in, I'll give you an example of something that I scanned in right here. So obviously, most of you guys know that I have a hobby company that makes products. So I sprayed this entire little model down. I sprayed this thing with vanishing spray. They make a couple of different versions. They make stuff that vanishes inside of about 4 or 5 hours, and they make stuff that lasts for a day. And that allowed me to draw this. I created a mesh with reference geometry, and that allowed me to design this so that it fits nice and clean on the first try. So you get accurate locations for body mounting positions and things like that. And so that's generally speaking the way we use the technology here. We scan items that allow us to then go in and draw or develop products that mesh up, mate up, or connect up very good on the very first try. That's the goal anyways. You don't want to have to iterate 4, 5, 6 times or just waste a huge amount of time. Yeah, someone says scan the file size is huge for laser scanners. Yeah, the thing is, you can go in here and any scan, if you let your scanner retrieve enough data or capture enough data, you can have millions and millions of vertices in these point clouds. And so the sophistication of the software that you use to process these point clouds significantly impacts your ability to manipulate them, model them. There are obviously very useful tools like VX Elements, Geomagic. Of course, Verisurf has a very, very nice reverse engineering software package. There's plenty of tools out there. What's happening now? I mean, right now, if you're watching this video on an iPhone, you can go download an application that will let your phone use its LiDAR to scan something. It doesn't do a very good job, for the record. I've tinkered with it quite a bit, but it is capable. And if you wanted to say model your house and put it in a video game or something like that, you very well could do that with your phone, believe it or not. But the real issue is just the entire global experience. From the minute you turn on the scanner, its ability to pick up the surfaces accurately export them into a point cloud, which then gets cleaned up and meshed, aligned. If you're trying to scan a whole car, you're probably going to scan it one panel at a time and align it. So all right. Well, I wanted to answer that question. So the short answer is if you have the budget and if you have the budget and the true need, I'm all for some of these higher end professional grade scanners. But I can tell you right now that I'm absolutely stunned with this inexpensive RevoPoint Pop 2 scanner. I may very well buy the mini when it comes out. And as insane as this sounds, I think the reverse engineering suite from Verisurf is about $7,000. I could totally see, I think these scanners are actually generating good enough data that if you could combine them with a powerful software suite, I think that you could really accomplish a lot on a very modest budget. So, all right. Question says, how is the Akuma? Have you gone to the limit? The Akuma's doing great. Love that machine. Works great. In fact, our little VM2 has actually been working out pretty great too lately. So I think that most of these scanners are designed for smaller objects. You're probably going to find the limits of your hardware, of your computer, to be honest with you, and you start getting into scanning really big things. I do know that the Peel 2, what's nice, something to consider if you're going to scan something big, you want something with a very large depth of field because you don't want to be scanning 6 inches from the panel everywhere you go. If you could stand off 15, 18 inches and capture large swaths of the panel, I think that'd be a lot more efficient when it came time to capturing those panels. Not only that, but a lot of the lasers that are out there, the laser-based scanners, they're not as sensitive to dark colored materials and shiny and or reflective materials. Sometimes they can even scan things that are transparent, which is pretty trick. So right now with the Revo, it comes with its own scanning and like mesh smoothing. That's pretty funny. The Revo comes with its own small software suite. You scan it in its own little app, and then it's got Revo Studio where you can kind of clean it up, smooth it out, patch holes, things like that. And then you export it out as a mesh file, and you can use any number of tools. I've actually been exporting most of our meshes. I decimate them to where they're manageable inside Fusion 360, and then I go inside Fusion 360 and I kind of turn them into B-reps or maybe a step file or some type of a surface like that. So, all right, guys. Well, I hope you guys got something out of this video. I hope you learned something. If you guys have topics or questions you guys want to know about, let me know. If you enjoy these short live videos, I know 20 minutes, still relatively short. Do me a favor and click the thumbs up button. It just tells Google to notify more of you guys that are interested in this kind of content. If you don't like these videos, then don't hit thumbs up, and hopefully Google won't notify you or YouTube won't notify you. So thanks for watching. Keep in touch, and we will see you very soon. I got a couple of videos I already shot and edited for the X7, and so I'm just waiting to. I don't know what I'm waiting for. I need to publish them so they're out. So all right, thanks guys. Enjoy your Sunday. We'll see you later. Bye bye.